this is your channel Susana Sauno, and on this occasion we are going to test this small electrical resistance. Let's see, let's get her closer. The resistance already has a written value, a lot of resistance. They have two ways to show you the value, or they have it written directly here, 250 ohms. With the symbol of the Greek letter omega, as we can see, if I can do it with a little more in the eye, that symbol is the Greek letter omega 250 ohm. This is the unit that measures resistance, the passage of current through this material. So this component is called electrical resistance because it opposes the passage of current. Well, in this case, this resistor measures, as it says here, 250 ohms. But let's check that. Let's check it out. For that, we are going to use our digital multimeter. We already have a connected test tip here. I'm going to connect the black one he was missing. Both are already on. It is worth highlighting, Condal, that this is the negative and this is the positive for most modes. Now, in the case of resistance, the positive and negative are not taken into account. That is, it can be connected in any way and resistance can be measured. We are going to configure the multimeter. For that, what we do is turn on the multimeter. Here it is on, and now within the modes we are going to locate. The omega symbol, look at it. Here is the unit of electrical resistance. Okay? Let's move it counterclockwise and let's get it right. What we do is we're going to put it here where it says 20,000. Let's see. Not here where it says 2002, 1000 kiloohm. That equals 2000,000 ohms because 2000 to the 10 to the 3. So here it says 200 kiloohms, which is 200 times 10 to the 3. So, and we're talking about 200,000. So in this case, we are talking about 2,000. And so how do we know? Well, in this case, we know the value. But if we don't know here, by testing from the highest value to lowering the lowest until it shows me a value on the screen. If the resistance value is very high and here the setting is very low, it will not show me the value. So the resistance value always has to be below the mode we select. That's important here. We're going to put it in this case at 20,000. We're not going to put it in 2,000. Yeah, now why did we put it in 2,000? Well, this resistance says it has value. A value we are going to approximate here has a value of 250 ohms, as we can 250 ohms. So here when we configure the multimeter between what value and what value is 250? Well, we observe that 250 is between 200 and between 2000. That tells me that the way I should select it is in 2000. Of the two, you always have to take that the topic is always high. Because 250 is less than 2000 but greater than 200. So if I put it at 200, it would be wrong because the resistance of 250. So you have to put the highest value of 200. The highest value is 2000. So there it is. Once it is put there, we can now connect the resistor to connect it. As I just told you, the resistance has no polarity. That means I can easily connect the resistance, so it will give me a value there. As we see, 250 volts, as you see. Look at it. There we are going to see how we see 251 ohms, 250 ohms, as we can see. Alright, perfectly. The multimeter is measuring the resistance well. It matches the value shown here. That means this resistance is in good condition. Look at it there, 250 ohms. Hold it there. Now look at something. If I connect the negative on that side, let's look at the multimeter there. As we can see, 250 ohms. Now I'm going to flip the resistance. Look at the LA. I flipped it for the opposite unit. Look at it there. They are measuring the same thing for me there. Let's see. Look at him there. 250 ohms. You mean if we connect the resistance, if we connect it, so if we connect it like this, and if we connect it, that's the same thing. It doesn't matter how you connect, it will give me the same value because the resistance has no polarity. I mean, it doesn't have a positive or negative. So these colors that we see here in electrical resistance mode, they are not important because this is only used as a reference for the voltage in direct current. But for example, in alternating current, these colors are not used for resistance either, as we can observe, and so then we can test the resistance. In a future video, I'm going to show you how we can do it also by color coding. In the case of this resistance, we cannot use the color code to calculate the resistance value, because here we are showing it with the digital multimeter. But there is also a theoretical way to calculate based on the colors, the range of colors that the resistance has on the surface. This resistor has no color band. What they do is they impress on you the value of resistance. On top of the one with the color strip, they will not tell you the value of the resistance written, because with the colors through a table, we can identify the value here. It says, look at this 2, look at this value that's here there. Perfect is the value we see there. 2W, 250 ohms. Those are the data they are giving me, because this resistor only has 2 ways to know: reading it on it or testing it with the multimeter in the case of those that have color codes that have stripes. Gold, red, and so they have it around those through the table for the color code. We can identify it through the multimedia, and so, well, that's all for today. Thank you for watching the video. See you next time. You can subscribe to the channel. I will accompany you in the manual. Any questions you can ask me in the comments box. You can follow us on our Facebook page, Susana Sauno, and also here on YouTube, Susana Sauno. See you next time.
Subscribe to our channel Susana Sauno in English and activate the notification bell to receive the notification every Saturday of new videos.